Hello everyone. Today I have created one YouTube channel, Instrumentation Concepts and Applications. In this channel, I will upload various engineering concepts related to instrumentation and their applications. The purpose of creating this channel is, although there are many videos over any topic, but when I checked them out, I found that rarely there is a video which has the complete information, like the standards on which that principle is, that concept is based, and their complete applications. That is missing. So I will try to make such a video that you don't have to refer any other video and you will get the complete information in single video. So introducing myself, I am having a total 10 years of experience in oil and gas industry in instrumentation and control engineering, and today's topic is hazardous area classification. So let's start. So to start with, the basic question is, why classify an area as hazardous? So before that, let's see what is the hazardous area. So hazardous area, also known as potentially explosive atmosphere, is defined as an environment that consists of any concentration of flammable gases, vapors, mist or combustible dust. And why classify an area as hazardous? We need to eliminate the potential of an explosion, promote the safety of the person, and prevent property damage. These three are the main objective to classify any area as hazardous. So the MSP of this video is, I have mentioned the regulation, guidelines and laws along with their standards which have been followed to identify area as hazardous. So unfortunately there is no specific certain guidelines on which we can classify the area as hazardous, but there are number of regulations and guidelines. Some of them are mentioned as OSHA, National Electric Code NEC, which is being followed in USA, Canadian Electrical Code CEC, National Fire Protection Association NFPA Article 17, and some insurance requirements are also there. And the standards I have mentioned in the right side, that is the main and the mother of all the standards is IEC 60079-10. This is electrical equipment to be used in hazardous area. And some Indian standards is also there, 5572, 5571. These are for guide for selection of equipment in hazardous area. It is being followed in India. IS 13408, this is code of practice for the selection, installation, maintenance of electrical apparatus for use in hazardous area. NFPA 497B recommended, this is for recommended practice for the classification of flammable liquids, gas or vapors and hazardous location for electrical installation in chemical process area. And you can see there are other standards also, but I want to mention the OISD, Oil Industry Safety Directorate 113. This directs you like classification of area for electrical installation and hydrocarbon processing and handling processing facilities. So these are the some standards which have been followed to classify any area as hazardous. So let's move further. There are also various approval agencies which certify any transmitter, any electrical equipment to be used in hazardous area. So if you are North American, if you are watching this video from North America, then approval agency will be different, and other than North America, Europe, Asia and other some bodies are also internationally accepted. So for example, factory manual FM approval is required in North America only, and CML, Certification Management Limited, this is being followed in Japan, and CSA, Canadian Standard Association, this is also being very much in practice in America and Canada. ATEX is something which is universally accepted across all across the globe. ATEX, and ATEX full form is atmosphere explosive, and IEC like this, you can see that SAA Standard Association of Australia is being accepted in Australia, and some other agencies are also there. In July 2003, a European directive called ATEX directive established, which is widely accepted in worldwide except USA. Before 2003, it was called Senelec certified. So if anywhere you see the Senelec is mentioned, nowadays Senelec is not there. The Senelec is renamed and rebranded as ATEX. The ATEX standards which have been followed for hazardous area classification is ATEX directive 94/9/EC. So if any equipment is ATEX approved, then there must be a CE marking on that approval. I will show you the typical standard marking of these instrumentation, then you will have a good idea. So this is the typical marking of hazardous area as per ATEX directive 94/9/EC. So first you can see that CE is mentioned. This is European Community, manufactured according to applicable as per EC directives. After that, there is a notified body. Number is 0575. So number is 0575. Just wait. Yeah, this is number 0575, notified body number for production surveillance. After that, this EX is mentioned. This is equipment. This marking is used for the material to be used in explosive atmosphere. After that, you can see there is some Roman language 2, 1 and G. What is the meaning of all this? EX, this is an IEC standards, EX, IES, Roman C, T4 and GA. What is the meaning of all this marking? We will see in the further slides. All right, so to start with, let's move to further side, so that we will come back to this slide for more detailed discussion. But let's start with another slide. Yes. So classification nomenclature, actually right now we have two nomenclature standards. One is being followed in America, North American countries, and the other one is being followed in rest of the country, Europe, Asia and other Africa continent. But so the class/zone system is being followed in rest of the country, and class and division system is being preferred in USA only. So class 1 stands for gas and vapor, zone 0, zone 1, zone 2. What is the meaning of zone wise categorization? We will see further conformity to US requirement. A is there, and after that some EXIA, Roman C, T4 and GA. What is the EPL, equipment protection level? We will see in the coming slides. And and on the other side we can see that there is a system which is being followed in USA, that is division. This is there. So in division 1 and division 2, two categories are there. Ignitable mixture present continuously or intermittently, and division 2 is ignitable mixture is not normally present. More or less both systems are same, and the more popular classification is class/zone system. Fine. So let's move further. So when we see the typical marking, that CEX, now comes that Roman second. I have highlighted this section, Roman 2, 2 and G. What is the meaning of all three? Actually, if in a certification you see these combination of these three letters, then in short they are telling the zone. How we can identify the zone from this marking? This can be referred from the below table. First thing, if you can see in the right side, there is zone 0, this zone 0, zone 20 and zone 1, zone 21, zone 2 and zone 22 is mentioned. Zone 0, if you come right, from right to left, then if you want to identify the zone 0, then the gas must be explosive item present in the atmosphere. Equipment category will be 1, which is mentioned on the above circle 2. This is 1. And what is the level of protection? That means the equipment is that much protective that it can sustain 2 fault at the same time, and the frequency is very high, and continuously for long period of frequently. Equipment categorized by continuously for long time or frequently. There are hazardous chemicals, hazardous gases are there. So this will be the equipment group will be the second. Wait. Yeah, equipment will be the second, and the equipment category will be the Roman second and Roman 2, and the equipment category will be 1, 2, 3 depending on the level of protection. 2 fault at a time, the 2 fault at the time, 1 fault at a time, and if in the normal operation is there, and thus we can define the zone. So if you are coming from right to left, then you can see what is zone 0. Gas should be there, equipment category will be 1, and the Roman other industries. For mining industry, this is basically the surface industry. So the surface type of industries can be defined from this mining. If mining is there, then that is a mining industry, and other industries are the surface industries. So Roman 2, 1, and gas. So this group defines the zone of that particular equipment. And further, let's proceed further. Yes, so yes, you can see that now I have highlighted this Roman C. So what is the Roman C? If you can see the table, if mines are used, then group and class will be 1. If explosive gases are present in the atmosphere, then 2A, 2B, and 2C is there. And I have mentioned some representative gases name. This is not the complete list. I have mentioned in the comment also, but this is not the complete list of gases, but these are the representative gases. Like for 2A, methane, ammonia, ethane, and propane is there, and for 2B all these gases are there, and for 2C, hydrogen and acetylene and carbon disulfide is there. So we need to see. And in case of explosive dust, third, 3A, 3B, and 3C is there. Flammable fibers, non-conductive dust, and conductive dust. So this is the categorization of gas classification, which type of gas is present in the system. Now comes this is the important slide in which I have mentioned that the category of temperature T4 is there. So T4 means T4 135 to 120 degree maximum surface temperature is defined by this. And there are some like T classes there, T1 and T2. In T2 you can see there is T2, T2A, T2B, T2C, and T2D is there. So for more detailed maximum surface temperature segregation, we have some segregation over here also, but we normally follow this. T2, T1, T2, and T3 is there. So, and there is ingress protection degree is also there, which is being widely used, like IP ingress protection is there. So if I see 65 equipment is there, then 6 is the first is the dust tight, and 5 is the jetting of water. So first is the dust protection, second is the water protection. So NEMA standards being published in 2004, I guess. After 2004 IP is more widely used than NEMA. So now normally 4 and 4X NEMA, indoor and outdoor, hose directed water and corrosion. This certification is more widely used, NEMA 4 and 4X. And coming to the EPL thing, GB thing, you can see what is the EPL. This GB tells you the equipment protection layer, EPL level is defined by the international standard IEC 60079, the assigned EPL of equipment indicates, this EPL actually indicates the risk level or likelihood that the equipment can become a source of ignition. So the EPL depends on the explosive atmosphere type. If that is gas, then it stands for G. If dust, then D, and M for mines. If here it is mentioned as G, so that means it is presented in gas. So GA, DA, MA, GA, DA and MA, these are very high protection. The equipment remains safe in normal operation even in rare fault situation, two fault at once. And GB, DB and MB, high protection, the equipment remains safe in normal operations also when fault occurs, single fault. Okay, and GC and DC, enhanced protection, the equipment remains safe in normal operation also, may have extra protection to minimize the ignition risk in fault situations. Fine. So this is the equipment protection level, this is the maximum surface temperature range, and this is the ingress protection degree. So in the next slide I will see the we will see the equipment category and protection type. There this table tells you that if a protection is if the protection is D type, then that is flame proof enclosure. If the protection type is E, then increased safety is there. If IA, IB and IC, intrinsically safe is there. IA can be used in zone 0, zone 1, zone 2. IB can be in zone 1 and zone 2 only. IC only zone 2. And similarly, molding, oil immersion, powder filling and P type pressurized enclosure is also there. This is the equipment category and protection type. How we can protect the equipment from being a ignition source. So these are those equipment categories. And on the right side table we can see that what is the standard being followed. This is very important. This is the MSP of my videos, that if any product is intrinsically safe, that means the concept is related with energy limitation, the energy being going into the hazardous area is being limited. So EXIA that is being followed by 60079-11, intrinsically safe, increased safety is being followed by 60079-7, and type and non-sparking, non-sparking in this concept is non-sparking, that is 60079-7 and 15. Flame proof, this is very important, EXD, which is 60079-1, and this is IEC standards. Other standards are also mentioned. We can refer and have a good understanding of these concepts. So this is all from my side, and I am thinking to prepare Telegram to introduce one Telegram channel also, where we can have a discussion on any topic, and how you like do you like my this first video. Please let me know to improve my further knowledge sharing session, and if you have any doubt, please mention in comment box, and don't forget, please like and subscribe. Goodbye.